Hello everyone, I'm Kaswak and today I'm excited to share a project I've done, which is an enterprise grade RESTful product catalog API in modern backend development. Building an app that just works isn't enough. It needs to be scalable, testable, and strictly architectured. In this video, I'll walk you through how I built the API from the ground up using Python, PostgreSQL, and SQLAlchemy while leveraging advanced architectural patterns and Docker containerization. Okay, let's coming to the problem statement. When applications start out as small scripts or prototypes, it's the common to see database queries tightly coupled with the routing logic. You might see raw SQL or ORM queries right inside the API endpoints. But as the project scales, this becomes a nightmare. The code gets fragile, business logic leaks into data access logic, and worst of all, it becomes incredibly difficult to test the application without spinning up a live database. We need a way to decouple these layers so the application could scale without technical debt holding it back. Okay, the solution I proposed is to solve this problem. I designed the system around two key architectural patterns, the repository layer and the unit of work pattern. Instead of our API routes taking directly to the database, they interact with an abstract repository interface. This acts as an in-memory collection of our database. If we ever want to swap PostgreSQL for any other database or use a mock database for testing, we can do it without changing any core business logic. Alongside this, I use the unit of work pattern to handle database transactions. It ensures that a series of operations either fully succeeds or completely rolls back, keeping our data perfectly consistent without polluting our higher level code with session management. Okay, coming to the architecture is separated into distinct isolated layers. First, a client makes an HTTP request. The API routing layer intercepts this, passing and strictly validating the JSON payload. It then passes control to the business service layer, which opens a transaction using the unit of work context manager. Then the service then queries or modifies the data through the product repository. Okay, the repository translates this request into asynchronous SQL commands via the ORM, hitting our PostgreSQL database. Finally, the unit of work automatically commits or rolls back to the transaction before returning the response to the user. Okay, coming to the tech stack I choose tools built for separate speed and reliability. Okay, coming to the programming language, I used Python, and the frameworks I used are for backend is fast API for blazing fast asynchronous HTTP routing. Okay, and coming to the validation, Pydantic to ensure all incoming data perfectly matches our strict schema constraints. And database, I used PostgreSQL 13 plus, assessed asynchronously using async PG. Coming to the ORM, I used SQLAlchemy 2.0. Okay, and testing, I used PyTest with fully mocked sessions for unit testing and real client request for integration testing. Okay, coming to the infrastructure, I Dockerized and Docker and Docker Compose for fully containerization, ensuring the app runs perfectly on any machine. Okay, let's see it in action. Okay, the API supports full CRUD operations. If I send a post request to create a product, you can see Pydantic validates it immediately. If I try to send a negative price, it throws an 400 bad request with a clear error message. The validation request returns a 201 created with an auto-generated UUID. Okay, we also have a get health endpoint built in. This is a critical requirement for orchestration tools like Kubernetes to monitor if our container is healthy and ready to receive traffic. Okay, now see how to run this app. Okay, because the entire application is containerized, running it locally is incredibly straightforward. You don't need to install Python or set up a local database. You simply clone the repository, set up the environment variables for the .env.example file, and run docker compose up -build. This orchestrates a multi-stage Docker build spins up a PostgreSQL container with a persistent volume and waits for the database to be healthy before booting the API server. It's production ready infrastructure right on your local machine. Coming to the future enhancements, while the API is robust, there is always a room to grow. Future enhancements I am looking at include adding a caching layer with Redis to speed up frequent read operations, implementing database migration tools like Alembic to manage schema evolution, introducing a message broker like RabbitMQ for handling asynchronous background tasks such as generating product reports. And coming to the final conclusion, building this product catalog API was a fantastic deep dive into modern enterprise backend engineering by enforcing strict architectural boundaries with the repository and unit of work patterns and utilizing non-blocking asynchronous Python. This application is highly scalable, incredibly fast, and 100% testable. Thank you for watching.